Okay, I will write it. Okay, so here you have a Q charge. Okay, so actually this value is 0, 1, 0. Okay, and here also you have a charge. Here also you have a charge. Okay, so that is 1, 0, 0. Okay, and your force is like this. This is the force in this direction. Okay, so you can see that this force is not either in X direction or Z direction or Y direction. Okay, so it has another direction. Okay, so here we should be careful. Okay, we should need to find the distance careful. Okay, so this is the origin 0. Okay. So now maybe you can compare this equation with this one with this equation, then you can find it easily maybe. Okay. Uh, so there is a direction here. This direction, that is AX. Sorry, what is this direction? What is this direction? Is it AX? Or what that? What is this direction? It is not. Is it AX? No, it is AY. Okay. This direction is AY. What is this direction? What is this direction? What is this direction? That is AY. This so X. X. This direction is X. AY, AX. Okay. AY, AX. Okay. And you need to find this direction. You need to find this direction. This unit. So first if you consider the, if you consider the, if you consider the, um, the total, so let's say that let's consider this total vector. So this is a vector. Okay, this is a vector. This force is a vector. Okay, so that is, okay, this force is a vector and this distance is also a vector. Okay, it has a direction. That direction is in this way. Okay, so if you consider that direction, that distance, okay, let's say that that is uh, this point is A, no? This point is C. This point is A. So let's say that this direction, this length is A R C B R C A from C to A. Okay, R from C to A. Okay, RCA. RCA. So can you find the magnitude of RCA? Can you find the magnitude of RCA? That means this length. This length. Can you find it? What you have to do? This length you can find easily. But what is you have to do? Actually, this is x-axis and this is y-axis. Okay. So these are, there is a 90 degree. Okay. To find this, to find this distance, what you have to do? You can use the Pythagoras equation. Okay. Pythagoras theory. This square plus this square root is this one. Okay, RCA. So RCA is 1 square plus 1 square root. So that is square root 2. This is RCA. Okay. So so keep remember, if you have any so if you consider two coordinate, if you have one point here and one point here, B. Okay. So if you want to find the distance of this A to B, what you have to do? Okay. Point A distance, let's say that that is um, AX, AY. Point B distance. Okay, I think I will mute that. There's a noise. Okay. Okay. I have muted. Okay. Mm, okay. And if you want to find so this point is AX, AY, and this point is a let's say that BX, BY. So how you find this AB distance? So you have to find this BX minus AX, that is this length, this length. That is BX minus AX. You have to square plus this length. That is BY minus AY. BY minus AY square. Okay. Then you can find this distance. So you have to get the difference and you have to square it. Okay. So if you have another point, okay, maybe another point in this direction, okay, okay. In this, if you consider this direction, the another direction, okay. So there, so this point will have a three. This point will have three coordinates, okay. So that may be AX, AY, AZ, and this will have three coordinates, BX, BY, BZ, okay. So to find the distance, okay, to find the distance between this A and B, so you have to get this x-axis terms, AX minus BX, you have to square it, AY minus BY, square it, plus AZ minus BZ, square it, okay. Then you can find the total distance, okay. Here also you can, if if you maybe in some point maybe you can't at once you maybe uh, this applying the Pythagoras theorem maybe not come to your mind, okay. So at that time, that keep remember that if you are given two location, and if you want to find the distance, so you have to get the corresponding x, y, z values subtraction, then square it and find the square root, okay. So that is how you can find this distance, okay. So here also you can use the same way. So x is 0, uh, here x is 1, okay. So 0 minus 1 is square plus here 1, y is 1, x is 0, so 1 minus 0 is square plus 0 minus 0 is square, that is 0. So 1 is square plus 1 is square, that is square root, and you have to get the square root also. So square root 2. So that is this value. Okay. So find the distance is not much difficult. What you have to do, you have to get the corresponding x, y, z terms subtraction, then square it and adding them together, then square root. Okay, get the square root. Okay. So that is, you can find the distance between 2 points, whether it is in 2-dimensional or 3-dimensional. Okay. So this will be square root 2. Okay. Now, the unit vector in this direction is what? This is the vector. RCA is the vector. And if you divided it by the unit vector, square root 2. Okay. Then this is actually the unit vector. Okay. Let's say that that is A CA. Okay. So this is the unit vector. This is the unit vector RCA divided by square root 2. So that will be ACA. Okay. So it is in other direction. It is in other direction. Okay. Uh, okay. Okay. So if you consider this again the Coulomb's law, F is equal to, let's say that this is F2, that is equal to 4, 5 epsilon naught epsilon R Q1 Q2 divided by R square. R square is A R1. Okay. A12 or something, no? A12 or something. We end up with this. Okay. A12. A12, this is R12. Okay. Uh, so, okay. So this RCA also you can find, okay. So you can't keep RCA, okay. You can't keep RCA. You have to find it with respect to X, Y, Z. Okay. You have to find it with respect to AX, AY, AZ. Okay. So first one we have found. First we have found AX. Okay. So this one also we have to found with respect to AX, AY, AZ. Okay. So this is correct. Okay. But we have to, this is correct. Okay. So if we use this one, okay, identical to this one. So our answer will be 4, 5 epsilon R Q1 divided by RCA ACA. Okay. Now we RCA square, sorry. Okay. So now we need to find this ACA in terms of X, Y, Z. So how can we find? Okay. So it is very easy actually. Here also it is found, okay, using this. So if this is R1 and if this is R2, okay, simple R1 and simple R2, okay. So uh, so here also I think in textbook maybe it is found, okay, please check. Okay. So you can see now, okay, if you consider this are vector, okay. So here this vector add to this vector is equal to this vector, no? Okay. This vector add to this vector is equal to this vector, correct? This vector. So that is the vector addition theory. Maybe you have learned it in, if you have like this, okay. So this is one vector and this is another vector, okay. So the resultant vector will be like this, okay. So I can't see, this is also vector addition rule, okay. I can't remember that rule name, okay. Anyone can remember that name? So there is a name for this rule actually, as I can remember, but now I can't remember that name, okay. So maybe vector addition rule or something, okay. So anyway, this vector add by this vector and this vector, okay. So this vector is R1, okay. This vector is, if this vector is R1, okay, I am considering the general uh, general status, okay, general condition, okay. So R1, that is vector, and R1 plus this is another vector plus R12, that is equal to R2 vector. Then R12 will be equal to R2 minus R1. Okay. So R12 you can find with respect to this one and this one. Okay. So what is R12? That is the total vector from here to here. So you can write this as R12 magnitude A12, that is the unit vector, is equal to R2 magnitude A2 plus R1, sorry, minus R1 magnitude A1. Okay. So this magnitude, you know, this magnitude you can find if you are given this coordinate system. As I can tell you, you have to get the corresponding X, Y, Z value subtraction and square them and add them together. Then you can find this value. Okay. So you can find the R12 magnitude, then R2 magnitude and R1 magnitude. Then A12 can be determined using A2 and A1. Okay. Okay. So here also we are going to do the same thing. Did you get this? If you have any problem, just ask me. Okay. I think you have already familiar with these things. Okay. So that is why I quickly explain. Okay. So maybe those should be in reference textbook also. I couldn't refer this book. Okay, I'm sorry. Today I doesn't have much time to see this book. Okay. මම දීපල්ලෙන් යනකොට මම දැක්ක ඔය වගේ එකක් තියෙනවා. හරි. Anything? Okay. So this is the unit vector R1. This is the unit vector R2. Okay. Maybe this R2 and R1 is not unit vectors. Okay, vectors. They have considered vectors. Okay. I think it is better if they use capital letters anyway. This is R1 vector. This is R2 vector. So R1 plus R12 is equal to R2. So R12 will be equal to R2 minus R1. Okay. This one. Okay. This one. That is what I explained there. Okay. R12 is equal to R2 minus R1. This is come from vector addition. Okay. Then, so this unit vector is A12. You need to find this unit vector A12 from this vector R1 and R2. Okay. So what you need to do, as I told you, okay. So this equation come, same thing I told you there. Okay. So R12 magnitude into A12 is equal to R2 magnitude this direction. Okay, this R2 direction are the unit vector. Let's say that R2 hat minus R1 hat. Okay, so like this. Okay, so then you can find A12 as R2 hat R1 hat divided by R2 hat R12 hat, capital R12 magnitude. Okay. So likewise, you can find this A12. Okay. This equation is somewhat different. Okay. So how this find? A12. Yeah. Okay. So R12 is equal to, actually this one also correct. Okay. This one also correct. Okay. So here it is not the same equation. Okay. So it is just, okay, this way also, okay. Okay. So here, so we get that R12 is equal to R2 minus R1. Okay. So here simple R2 minus simple R1. Okay. So if we get R12 magnitude, that is equal to simple R2 R1 magnitude. That is the equation. Okay. So if you want to find R12 unit vector, that means you have to find R12 divided by R12 magnitude. Then you will get A12. So R12 is equal to R2 minus R1. divided by R12 magnitude. So that means R2 R1 magnitude. Okay. So the same things, same concept is there. Okay. Okay. So so if you can remember the vector addition rule, so you can get it. Okay. So in the same manner, here also you can get that value. Okay. So here, see that. Okay. So if you consider this one, AY and this one. Okay. So this is this way, no? Okay. So this vector plus this vector is equal to this vector. Okay. So I will write this vector as C. This is C, no? Okay. So this vector is C. I will write this vector as C. Okay. Okay. This vector as C plus this vector RCA equal this vector. This vector is A. Okay. So RCA is equal to A minus C. A, so A minus A. Okay, I corrected right now. C plus RCA is equal to A. So RCA is equal to A minus C. Okay. So, um, so we need to find the magnitude of the RCA. No? Okay. Okay. Now tell me, uh, this is A. This distance is the A. Okay. So this, what is this value? That is 1. 1. Okay. So 1 into AX, that is the unit vector. Okay. So A vector A is equal to 1, that is the magnitude AX. Okay. And this is vector. These are vectors. Okay. And vector C is equal to what? This C. This one is equal to what? Please tell me. මේක මොකේද equal වෙන්නේ? මෙතන නම් මෙතෙන්ට දුර ඒක වෙක්ටර් එකක්. හරි? එයාගේ යුනිට් වෙක්ටර් එක AY, ඒකේ ස්ටෑන්ඩඩ් එකක් AY. හරි? මෙතන නම් මෙතෙන්ට දුර කීයද? දුර ඔයාලට මේ කෝඩිනේට් තියෙනවා නම් හොයාගන්න පුළුවන් ඕන වෙලාවක. හරි? දුර කීයද මෙතෙන් මෙතෙන්? මෙතන මේ 0 නම් මෙතෙන්ට දුර කීයද? What is the length from here to here? Actually, we are considering the length, okay, not the distance. Okay, because distance has the direction, okay, but length doesn't have a direction. So this length, okay, what is this length? My length here. Can anyone tell me what is this length? Very easy. Make a length. Yes, that is 1. This length is 1. Then what is, so we get this vector as C. We get this vector as C. So, and the unit vector is AY. So then what is the C? What is C? Vector C is equal to what? If you have a vector R, and if you divided it by magnitude of R, you will get a unit vector R hat. Okay. Then your vector R is equal to vector. This is a vector is equal to R hat, R magnitude into R hat. Okay. Yes. Very good. So R hat, that means the vector. So C hat, that is this vector. C hat is equal to the magnitude of C. Magnitude of C is 1. And the unit vector of C is AY. So that is the standard direction, AY. Okay. So normally we are putting a bar to a vector. That is what I am using. Okay. I am familiar to do. Okay, maybe you may be not familiar with that notation, but anyway, all are same. Okay, so different notation are used. Vector අමාරු වෙලා තියෙන එකකින්. හරි නැත්නම් vector කියන subject එක හරි ලේසි. vector වල තියෙන ওই Pythagoras ප්‍රමේය දාලා හෙට මෙහෙට දාන්නේ. එනකොට ඔක අමාරු වෙන්නේ එක එක පොත්වල තියෙන එක එක notation. හරි? ඒ කියන්නේ ඒකට හරියට standard එකක් නැහැ. එක එක කට්ටිය පාවිච්චි කරන්නේ එක එක notation. Okay, that is why it is somewhat difficult. Okay. එතකොට right දැන් අපි හොයාගන්න මේක 1x minus 1ay. Okay, now RCA is equal to ax 1ax minus ay. Okay, that is the vector. Okay, and you have to divide it by RCA magnitude. So what is the RCA magnitude? RCA magnitude we have already found, that is root 2. So if you divided this by root 2, okay, so this is the RCA unit vector. That is we denoted that ACA. Okay, so this is the unit vector. Okay, so instead of this ACA, you have to put this F2 is equal to 1 over 4, 5 epsilon naught epsilon R. The charge is Q. So Q into Q, that is Q is square. Q is square divided by RCA square. Okay, RCA is actually 2. Okay, this is magnitude. Okay, this is magnitude you have to consider. Anyway, if the vector is square, it will become the scale. Okay, yes, because here you have to get the dot product. Okay, so it will be a scalar. Okay, so it will be 2. It will be 2, and this is ACA. So this is ACA is this one. That is AX minus AY root 2. Okay, so we have found F2 also. Okay, now you have found F2 also. Then what you have to find? You have to find this F3 also. You have to find this F3. So you can easily find that F3. Okay, I will write it. Okay, okay. So here, this is the origin. This is the origin. And you have D location. Okay, and this is the origin. Here you have A location. Then from here, okay, from here there is a force like this. This is F3. Okay, so if this is O, okay, F3 is equal to 4, 5 epsilon naught epsilon R. So here Q, here Q. So Q into Q, Q is square divided by this distance. Okay, this distance. That is, let's say that this is D and this is A. Okay, so RDA. Okay, so it is RDA square into the unit vector. Unit vector, let's say that that is ADA. Using our normal notation, ADA. Okay, so unit vector is ADA. Okay, so if you know this one, and RAD square, you can easily find what is that? That distance from here to here. So how you find it? Okay, so this location is 1, 0, 0. This location is 0, minus 1, 0. 0, minus 1, 0. Okay, so how you find? this one. Okay, so you can use the Pythagoras, no problem. Okay, so you already know that this is 1 and this is 1, so this will be square root 2. Okay, so RDA, the RDA magnitude will be square root 2. Okay, RDA magnitude will be square root 2. Also, you can find it by subtracting this point. Okay, 0 minus 1, that is minus 1 square, plus minus 1 minus 0, that is again minus 1 square, plus 0 minus 0, that is 0. Okay, so and you have to get the square root. Okay, so 1 is square 1, 1 minus 1 is square 1, minus 1 is square 1. So you will have square root 2. Both way you can find. Okay, okay, okay. Now what is the challenge? You need to find the unit vector. The unit vector of RDA. To find that, you know RDA, and if you divided it by RDA square root, you can get the unit vector, that is ADA. Now you need to find this unit vector using XYZ direction, XYZ unit vector direction, because those are the standard one, AX, AY, AZ. Using this unit vectors, you need to find the ADA. So how to find? Can you find? So try to find it, just get 5 minutes and try to find this. Get 5 minutes and try to find this. No need to send the answer. Okay. If you can send the answer. Otherwise, just try 5 minutes and try to find this. Try to find this. This unit vector ADA. This unit vector ADA by means of AX, AY, AZ. So it is also very easy. Okay. This direction is this way, and this direction is this way. This direction is this way. Okay. Okay. Okay, I will. So anyone can find, anyone could find the ADA. Actually, that is what that is the only thing we need to find, no? This one, ADA, because we already know RDA square, that is square root 2. Okay, so these terms are also we know. Okay, so we have to find this one, ADA. Okay, so very simple. All questions are in this type. Okay, so very simple. Okay, so that is not much difficult. Okay, so if you consider that one, okay, if you consider that one, okay, so this is F3. Okay, so now if you consider uh, this one plus this one is equal to this one. Okay, so let's say that this is okay. Now tell me, what is this unit vector? What is this unit vector? Tell me, what is this unit vector? I need that answer. What is this unit vector? Just give me the answer. ඔකට හිතන උත්තරේ දෙන්න මොකක්ද කියලා. මොකක්ද මේ මෙයාගේ unit vector එක? What is his unit vector? මොකක්ද මෙයාගේ unit vector එක? ඒ කියන්නේ මේ D ගේ unit vector එක මොකක්ද? දැන් මෙතන ඉඳන් මෙතෙන්ට vector එකක් නේ. එයාගේ unit vector එක මොකක්ද? What is his unit vector? That is a standard unit vector. That is AX, AY, or AZ unit vector. So what is his unit vector? Tell me. So I need that answer, okay? You are there, no? So I need that answer. Please give me that answer. Yes. No, 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 no. That is not AD, okay? That is not AD actually. Because this is a standard one also, you correct, okay? So if you consider this AD, okay, so that is AD. That is the normal notation. But this AD can be represented using this one, AX, AY, AZ. These are standard vector. AX is the x-axis unit vector, AY is the y-axis unit vector, Z is the z-axis unit vector. So AD is equal to what? Actually, this is related with the standard unit vector. So so your answer is related with the notation. That is the notation we use here. Okay. If this is the D is the vector, if the D is the vector, the unit vector is AD. That is how we define it, how we notate it. Okay. Vector D is divided by the magnitude of D. We have the unit vector AD. Okay. But now what we need that unit vector using X, Y, Z. So what is this? Please tell me. Please tell me that answer. Another answer, give me another, only one answer. Okay, I got to answer A1. Hmm, ඔල්ලෝ මෙතන මේවා පටල ගන්න එපා. මේක මේ අර මෙතන ඇත්තටම අර J terms එන්නේ නැහැ මෙතෙන්ට. හරි. J කියන්නේ ඒ කියන්නේ අපි කම්ප්ලෙක්ස් ප්ලේන් එක සලකනකොට තමයි ඔය J terms එන්නේ. හරි. අපි ඇත්තටම මෙතනදී කම්ප්ලෙක්ස් ප්ලේන් එක සලකන්නේ නැහැ. මෙතනදී අපි ඒ කියන්නේ ඔය දැන් x y z ඔය කෝඩිනේට් එක එක ඒවා තියෙනවා. හරි. එකක් තමයි අපි කම්ප්ලෙක්ස් ප්ලේන් එකත් ඔය XY වලින් කියනවා මෙහෙම කාර්ටීසියන් කෝඩිනේට් එකෙන්. හරි. එතකොට අපි මේක x axis එක real axis එක y axis එක imaginary axis එක කියලා ගන්නවා j විදිහට. හරි. එතකොට ඔයාගේ උත්තරේ හරි. හරි. ඔයා කියලා තියෙන එක හරි ඇත්තටම. මේක y axis එක අපි ගත්ත මේක y axis එක විදිහට. හරි. මේක y axis එකේ ඍණ ඩිරෙක්ෂන් එක මයිනස් ඩිරෙක්ෂන් එක. ඒකින්ද ඔයා කිව්වා ඒක -j කියලා. හරි. ඒකේ වැරද්දක් නැහැ. ඒක හරි. හැබැයි ඒ කම්ප්ලෙක්ස් ප්ලේන් එක නම. This is not a complex plane. මේ අපි කම්ප්ලෙක්ස් ප්ලේන් එක නෙමෙයි සලකන්නේ. හරි. කම්ප්ලෙක්ස් ප්ලේන් එක කියන්නේ කම්ප්ලෙක්ස් නම්බර් එකක් අපිට කම්ප්ලෙක්ස් ප්ලේන් එක ඩිෆයින් කරන්න පුළුවන්. අන්න ඒ වෙලාවට තමයි ඔය J ටර්ම් එක එන්නේ. හරි. තේරුණාද? Did you get that? I hope you can understand Sinhala, okay? So, okay. If you get it, that is okay. Okay. So anyway, thank you for your answer. Okay. So, if you are given wrong answer, maybe you can verify it. Okay. So you can understand the situation. Okay. If you are silent, you will never understand the things. Okay. So anyway, thank you for your question answer. Okay. Okay. So actually, this is not AY. Okay. So one student gave me the answer as AY. This is not AY. What is that? So this is y-axis. That is correct. Okay. So y-axis, we consider the unit vector as AY. Y-axis unit vector as AY. Okay. But what is this? This is direction, minus direction. So what is this direction? Vector always has a direction. Okay. So if you get x direction as this way, okay. So this way will be minus x direction, minus direction. Okay. So if this is unit vector ax, this direction will be minus ax. Okay. So this will be, so that is where you should be careful. Okay. So this should be minus ay. This should be minus ay, not plus ay. Okay, did you get it? This is not ay. This is minus ay. Okay, this direction is minus ay. ඒ කියන්නේ අපි සලකන පැත්තටම ගන්න ඕන. අපි කලින් ඒවා හැදුවේ මේ පැත්තනේ අපි ප්ලස් විදියට ගත්තේ. In our previous solutions, හරි. මේ solutions වලදී we get this direction. Okay. Here, this direction as ay. Okay. Then this direction will be minus ay. This direction as az. So this direction will be minus az. This direction as ax. So this direction will be minus ax. Okay. So you have to consider the same direction. හරි. ඔයා ගන්නකොටම මේ පල්ලෙහා ධන විදිහට ගත්තා නම් ප්‍රශ්නයක් නැහැ. එහෙනම් අනිත් පැත්ත ඍණ විදිහට ගන්න. හරි. Okay. Did you get it? Did you get it? Okay, thank you. Okay. Okay. So, okay. So this is minus direction, minus ay direction. Okay. Minus ay direction. And this is RDA. We get this RDA. This is as plus. Okay. So this way. vector plus this vector is equal to this vector. Okay. So this vector I will directly write. The magnitude of this vector is 1. And the unit vector is minus ay. So that vector is minus ay. This vector d. Okay. This is vector d. Plus vector rda. Okay. Vector rda is there. Okay. That is rda is equal to this vector. Okay. So what is the magnitude of this vector? What is the magnitude of this vector? That is from 0 to 1. 1, no? That is magnitude is 1. Okay. So that is magnitude is 1. What is the direction of that vector? What is this vector direction? That is ax, no? Okay. So it is ax. Okay. So actually this is a vector a. Okay. So vector d plus vector rda is equal to vector a. Okay. Then rda is equal to ax. Here, when it come here, it will be plus ay, not minus a. It will be plus a. Okay. Then to find the ADA, you need to find the unit vector. You need to find the unit vector along this axis, ADA, the unit vector of RDA. Okay. So you have to divide the RDA by its magnitude, RDA magnitude. So here also you need to divide RDA magnitude. So what is that? RDA magnitude is root 2. So ax plus ay divided by root 2. That is ADA. Okay. So F3 also you can find. F3 also you can find. F3 also you can find 1 over R5 epsilon naught epsilon R Q square divided by RDA square, that is root 2 square. Root 2 square, that is 2. Okay, that is 2 into ax plus ay square root. Ax plus ay square root. Okay, so this is F3. Okay, now you have found F1. Can you remember what is F1? That is epsilon, epsilon r, epsilon naught, q square, 2 is there. Okay, 2 is there. That is due to this one, no? So it is like this. Okay, so it is in ax direction. Okay, so that is ax. Okay. Then F2 is, these are there, 4, 5 epsilon naught epsilon r q square 2. What is the unit vector? This one, ax minus ay root. Ax minus ay root. Then how to find the total vector? How to find the total vector? Okay. So you have F1 in this direction, F1 in this direction, F2 in this direction. So, so you will have F1 this direction F1, okay, this direction F1, okay, F1 this direction F1, okay, this is due to this one. Then F2 this direction F2 එක මෙහෙම. මෙන්න මේ වගේ ඩිරෙක්ෂන් එකක් නේ. මෙතන ඉඳන් පටන් ගන්නෙ. මෙන්න මේ වගේ ඩිරෙක්ෂන් එකක්. මේ වගේ ඩිරෙක්ෂන්. That is F2. F3. F3 this direction. මෙන්න මේ වගේ direction. Okay. So you have F1 here in this direction. F2 in this direction. F3 in this direction. F2, F3. This is F1. So how to find total vector? This is the total force. So this will be the total force. F total. So how to find the total force? Ft. That is F1 plus F2 plus F3. So it will be F1 plus F2 plus F3. Okay. So that is the total one. So total is F1 plus F2 plus F3. Okay. So all these terms are same. Okay. So this 4, 5 epsilon naught epsilon r 2 u square. These are same. Okay. And here you have ax plus ay square root 2 ax square root 2 ay square root 2 plus ax, this one ax plus ax square root 2 minus ay square root. And this one cancel out. Okay. This one cancel out. So you will have 2a square root plus ax. So you will have like this. Okay. So 1, 4, 5 epsilon naught epsilon r square u square. Okay. You will have, you can get out ax. So here you will have 1 over square root, 1 over square root. So that will be 2 over square root. 2 over square root means square root 2 plus this one, 1. Okay. So this is the total force. This is the total force. It is in ax direction actually. That total force in is ax direction, this direction. That may be okay, no? Because you have 1 in ax direction like this, and same here, F2, sorry, F3, and same here, F2. So maybe this one, and if this angle and this magnitudes are equal, then so the resultant of this force and this force will be in this direction. So the total, and so that is, so this, the resultant of this 2 is added to this one. So you will have the in this direction. No? So maybe, so you can verify that our answer is correct. තේරුණාද කියවේ? හරි. දැන් මේක දැන් ඔකට තේරෙනවා දැන් මෙතන තියෙන්නේ. හරි. මෙතනත් 1 මෙතනත් 1 distance එක. හරි. එතකොට මෙයාත් කොහොම එනවා? මෙයාගෙන් කොහොම එනවා එකක්. මෙතන තියෙන එක්කෙනාගෙන් මෙහෙම x axis එක දිගින් එනවා. එතකොට මේකත් සමානයි මේකත් සමානයි. ඒ වගේම මෙයාගේ බලයත් සමානයි magnitude එක සමානයි magnitude එක සමානයි. හරි. මතක දාවේ ax plus ay square root 2 ඒ කියන්නේ magnitude මේ කියන්නේ direction එක වෙනස් බලය සමානයි. අනිත් එක යාවේ ax minus ay magnitude 2 square root 2. ඒ කියන්නේ මේ දෙන්නගේ බලය සමානයි. හැබැයි direction එක වෙනස්. ඒ කියන්නේ vector සමාන නැහැ. magnitude සමානයි. එතකොට මේ බලයයි දෙකේම සංප්‍රයුක්තය ඉන්නෙත් මෙතනින්මයි. එතකොට මේ සංප්‍රයුක්තය එකතු කරාම ඒකත් x axis එක දිගේම තමයි එන්නේ. හරි. So that means this answer should be correct. This answer should be correct. Okay. So maybe we have done some simplification mistake maybe happen. Okay. So anyway, I think You got this, no? So I think if you, so this is with the Coulomb's law, okay? So all things are like this, okay? All questions are like this. If you have this understanding, you can do this, okay? Related with the Coulomb's law, if you have this understanding, you can do, okay? So what you have to do, uh, most probably these questions come in rectangular coordinate, okay? So this question, Coulomb's law questions come in rectangular coordinates, okay? Not spherical or cylindrical coordinate. Okay? So if you have this understanding, that will be okay. Okay. So maybe using the Coulomb's law. Okay. You another term is defined, that is the intensity, electric field intensity. Okay. So that is defined as F divided by Q. So that is intensity means the charge, the force generated by a charge at a unit charge at 1 coulomb. Okay, at 1 coulomb is referred as E. Oh, okay, so instead of this Q, Q1, Q2, there should be one Q, only one Q. Okay, because other one will be a unit charge, 1 coulomb. So this methodology is there also. Okay, this methodology is there. Okay, so maybe now you can try to do these questions. Okay, try to do this question by yourself. Okay, especially this one, because solution is there, you can check the solution correct or not. Okay. Sorry. Okay, then maybe you can do this one also. Okay, so solution is there. Okay, so try to do this example. Okay, we try to do these two examples. Okay, and yeah. So field from the volume charge. Okay, field from the volume charge. Okay, so uh, before finding the, so normally when in this type of question, you will be given what is called charge density. Okay, so here V is there. This V refers to the volume. Okay, so this will be the volume. This will be a volume charge density. This will be a volume charge density. Okay, so if you need to find the total charge density, you should have to do the volume integral. Okay, so you should have to do the volume integral. Okay, okay. One concern is there. I think Dr. Udesh said that he has done one questions. I think this question he has already done. Okay, so this is in rectangular coordinate. Okay, so you are given uh, charge density. You are given a charge density, and you are asked to find the charge, the total charge of this sphere. Okay, this is square. Okay, so square is given. Sorry, not square, no, cylinder is given. Okay, so this is in cylindrical coordinate. Okay, this is in cylindrical. Okay, so what you should keep remember. Okay, no need to understand. I hope you have to keep remember. If you need to do the volume charges, okay, let's say that you are given a function x, y, z, okay, in rectangular coordinate. If you are doing the volume charges, okay, volume integral, so x should be there, y limit should be there, z limit should be there. So you can do the integral first with x, then with y, then with z. Okay, so this is very easy. Okay, but if you are using spherical coordinate, okay, so you have to do it by rho, you have to do it by 5, then you have to do it in z direction. Okay, so your function will be rho 5z. Okay, so you will given a function with in spherical coordinate. Okay. And so here dx dy dz, but it is not in this case, the rho is there. Okay. So rho term is there. Rho d5 dz. Okay. This is spherical coordinate, sorry, cylindrical coordinate and spherical coordinate. Okay. So you have to do the integration from uh, r theta 5. Okay. And your function will be given in r theta 5. Okay. This function will be a scale. Okay. And you have to do the volume integral. Okay. So it will be r square sine 5 d5 dt drs r square sine 5 dr d5 dt. Okay. So this you need to maybe keep remember. Okay. I will ask Dr. Udesh. Okay. So maybe if you need this for exam, maybe this equation will be your exam may be in open book, no? Okay. So I think you no need to keep remember, but you have to do, you have to have this idea. Okay. I will show it. Uh, just give me a 5 minutes. Mm, Udesh sir के recorded video तो බලන්න බැරි. You couldn't watch Udesh sir recorded video? Yeah, I think no. Is that Udesh sir's video? I think he has uploaded it to YouTube as maybe as a private or something. Okay, not in public domain. Okay. So you are talking about Dr. Udesh recorded video? Hmm? Are you talking about Dr. Udesh video? Yeah, yeah. Yeah, I will ask Dr. Udesh. Okay. I think in last time also the same problem is there. That is for lateral student, I hope. Okay. Anyway, I will ask. Okay. Okay, just give me a moment. Okay. So you should have this understanding, okay, about the coordinate system, okay. Uh, so as I told you, this is a position vector, okay. This is a position vector. So position vector can be represented like this, okay. So this is Z, Y, X, okay. So this you have to use your right hand to get this direction, okay. So in spherical coordinate, that is r theta 5, okay. So r is the angle, sorry, r is the radius, and theta is the angle from z axis, and 5 is the angle from x axis to y direction, okay, in this direction, okay. So these are also vectors, sorry. මේවා රවුමට මේ අපි ගත්තට කොන ඔයා රවුමට නෙමෙයි සලකන්නේ. ඔයා වෙක්ටර් විදියට සලකන්නේ කියන්නේ ඔක. r තියෙන්නේ මේ පැත්තට නම් හරි r මේ පැත්තට theta මේ පැත්තට හරි 5 මේ පැත්තට 5 තියෙන්නේ thetaට අංශක 90ක් මේ පැත්තට 5 මේ පැත්තට හරි r මේ පැත්තට theta මේ පැත්තට theta මේ පැත්තට r අංශක 90ක් theta මේ පැත්තට 5 තියෙන්නේ මේ දෙන්නට අංශක 90ක් හරි ඒක සිලින්ඩරිකල් කෝඩිනේට්ස් වල මේක මේ විදිහට එනවා හරි ඒතර කට්ටියට මේ අර දෙපැත්තේ මේ වගේ අර මේවා නම් එච්චර අමාරු නෑ මේ අර අනිත් ඒ වගේ මේවට කොහොමද මැප් කරනකොට එන්නේ කියලා. හරි. සිලින්ඩරිකල් වලින් රෙක්ටැන්ගියුලර් වලට මැප් කරනකොට රෙක්ටැන්ගියුලර් වලින් සිලින්ඩර් වලට මැප් කරනකොට එන විදිය. මේ පෙන්නලා තියෙන මෙතන මේ R මේ පැත්තට θ කියන්නේ මේ ඊට අංශක 90ක්. හරි. මෙයා මේ කරකවල ගත්තට මෙයා මේ විදිහට ගන්න වෙක්ටර්ස්. හරි. මේවා වෙක්ටර්ස් හරි. And phi is in direction of this both r theta plane. This phi is perpendicular to r theta plane. Okay, r theta plane. Okay, this phi is perpendicular to r theta plane. Okay. Uh, Actually, these spherical systems we normally referred as orthogonal curvilinear coordinate system. Okay, because these coordinate systems or the coordinates are orthogonal to each other. Okay, this x-axis, y-axis, and z-axis are orthogonal. They are independent to each other. So that is why it is called as orthogonal curvilinear coordinate system. Okay, so this is the general solutions for position vector. Okay, this is a general solution for position vector in UVW plane. Okay, so this in rectangular coordinate, this U is identical to X, V means Y, W means Z. Okay, so this is a general. Okay, these are the general terms, some position vectors. Okay, so using this position vector, we can get other position vector. Okay, for example, this is the position vector in cylindrical coordinate. Okay, this is a position vector in cylindrical coordinate. So in rectangular coordinate, you can see that. Okay, if you have to follow up this method. Okay, then you can find that. Okay, for a for a for a rectangular path, the position vector, the derivative of dr of the position vector will be dx x hat dy y hat plus dz z hat. This x y z are the x hat y hat z hat are the unit vectors like this. Okay, but if you want to represent this using what is called the spherical coordinate, this dr will be cylindrical coordinate. Okay, so spherical will be like this: dr r hat r d theta theta hat r sin theta d phi hat. Okay, so here it will become dr r hat plus r d theta phi hat. Okay, r d theta theta hat plus මම ඩිස්කනෙක්ට් වෙනවා මට තේරුණා ඩිස්කනෙක්ට් වුණේ කොහෙද කියලා. දැන් මේ ඔකට්ටියට ගොඩක් වැදගත් නෑ මම මේ අන්ඩර්ස්ටෑන්ඩින් එකක් ගන්න කියන්නේ හරි. සමහරට ඔකට්ටිය තව ටිකක් ඔළුව විකාර වෙන්න පුළුවන් මේ ඇහුවට පස්සේ. එහෙම වුණොත් මේක අමතක කරලා දාන්න හරි. නැත්නම් බලන්න පොඩ්ඩක් තේරුම් ගන්න පුළුවන්ද කියලා. හරි. එතකොට මේ විදිහට තමයි එන්නේ. හරි. දැන් මේකේ බලන්න දැන් මේකේදී නම් x y z ආවේ. dx dy dz වලට කෙලින්ම x y z ආවේ. එතකොට ඔකට්ටිය යුනිට් මේක ගන්නකොට if you have x, y, z function, so you can directly get dx, dy, dz, no issue. But if you consider this one, this is spherical. Okay, so if you want to get the unit one, okay, so r hat related with dr, so no issue dr, but d theta related with r. Okay, so r is there, r d theta. Here r sin theta d theta, r sin theta d theta. So it will become, okay, some function r square r square sin theta d phi sorry, r sin theta dr d theta d phi. So it is that is how it come. Okay, that is how this yeah, that one we have right, this term one. Okay, so here it is theta. Okay, okay, so you can see that uh, for a Cartesian coordinate, it is directly dx dy dz. For a spherical coordinate, it is rho d theta d5 dz. In spherical coordinate, it is r square sin theta dr d theta d5. Okay, so that is what you understand. Okay, ඒකට ඒක තියෙනවා නම් ඔකටට ඕන එකක් හදන්න පුළුවන් නේද? හරි? මේ අන්ඩර්ස්ටෑන්ඩින් එක තියෙනවා නම් ඔය කොහොම කරකවලා දුන්නත් හැදී හැදි ගන්න. හරි? So basically you should have this understanding. Okay, ගානට නෙවෙයි. මේ අන්ඩර්ස්ටෑන්ඩින් එක තියාගන්න. ඒ කියන්නේ ඔයාලට මෙතනදි මතක තියාගන්න ඕන. What you have to understand is that keep remember actually if you couldn't understand. Okay, so this is the case for a spherical coordinate. So r sin theta is there. This is the case for cylindrical coordinate. So rho is there. Okay, so when you are finding the unit in the volume integral, okay, so in Cartesian coordinate you can directly uh, integrate with respect to dx dy dz, but in spherical coordinate you can't directly integrate it dr dt d5 spherical coordinate. Okay, so there is r square, this r sin theta, r square sin theta is there. So r square sin theta dr d theta d5, you have to consider this one. Okay, in cylindrical coordinate also rho is there, d rho d5 d. Okay, so basically you should keep remember these two, this one this spherical coordinate and this cylindrical coordinate. Okay, so then you can find any charge volume. Any charge volume, you will be given this kind of a function. Okay, so and also you will be given the limits. Then you have to do the simple integration. Okay, integration කරන්න පුළුවන් දෙයිද කියන එක මත තමයි එතකොට ඒක පවතින්නේ. හරි? හරි? So I hope that is also okay. I hope you can do this question by yourself also. Okay. So in next week, we will try to do this one or two question related with this line charge and surface charge. Okay. Then we can move to the chapter 3. Okay. So shall we stop now? I hope you got the idea. Okay. How to use Coulomb's law. Okay. Maybe you can try some questions. Okay. So try some question. If you have any problem, you can ask me. Okay. Next week, you can ask me. Okay. Okay, so shall we stop now? Do you have any problem? Or if you doesn't have any problem, you can leave. Okay. So this is a tutorial session. So I think no need attendance mark. Okay. Anyway, we will get the attendance mark. Okay. We will mark the attendance. Maybe Dr. Udesh will. I don't know. Maybe he will. If you are not familiar with the coordinate system, you can refer this video. Okay, maybe you can refer this video. So පොඩ්ඩක් බලන්න මේක තේරෙනවද? මේකේ පොඩ්ඩක් අර ටිකක් ගැඹුරට තියෙනවා. හරි? පොඩ්ඩක් බලන්න මේ මොනවා මම දාන්නම් මේකට chat එකට. හරි? ඒකට ඒක පුළුවන් නම් චුට්ටක් බලන්න. හරි? බැලුවේ නැතත් ප්‍රශ්නයක් නැහැ. හරි? බැලුවේ නැතත් ප්‍රශ්නයක් නැහැ. නිකන් බලන්න පොඩ්ඩක් මතක් කරගන්න. හරි? මේක අර මේවා කොහොමද වෙනස් වෙන්නේ අර අරව ගන්න හැටි පොඩ්ඩක් මට මතක හැටියට එක්ස්ප්ලেইন කරලා තියෙනවා. හරි? ඒක පොඩ්ඩක් බලන්න. ඉන්න බලන්න attendance mark කරන්න පුළුවන්ද කියලා. Okay, you can mark the attendance. Okay, you can mark the attendance and leave if you doesn't have any question. Okay. If you have any question, you can ask me.